In this video, I will be going over week 33 AM work, day 3, and day 4 answers. So let's look at our first one on day 3, 476 plus 498. That is a simple addition of 3-digit numbers. So I'm going to write my algorithm here, 476 plus 498. Remember, the most important thing when you do this is that you line up ones under ones, tens under tens, and hundreds under hundreds. Okay. Then the next thing to remember is you always start with the ones. So 6 ones plus 8 ones is 14. And that means 1, 10, and 4 ones. Then you add the tens. 1 plus 7 plus 9 will be 17 tens, which means 107 tens. And then last but not least, you add the hundreds. 4 plus 4 plus 1 will give you 900s. And our answer is 974. Okay, let's go to the next one. This is a fraction problem, and I have a square here, and it is divided into 8 equal parts. That means eighths, and it says write the fractions shown. Well, there's 1/8, 2/8, 3/8, 4/8 shaded, so the fraction shown is 4/8. And that represents the shaded part, but you could also say 4/8 represents the unshaded part as well. All right, next we have a word problem, and it looks like it's going to have us practice time. Timothy parks his car at 4:03. He wants to visit the bookstore, so he puts enough money in the parking meter for 1 hour. What time should he be back at his car? Well, remember, elapsed time, we usually draw a number line for this. So that's what I'm going to do here to show where I got my answer. Okay, and put arrows at either end, and we're going to start at 4:03. That's when he parks his car and he puts his money in the meter. And he puts enough money in to last 1 hour. So on my number line, I will show a jump, a big jump. And that represents 1 hour, so I would put plus 1 hour. And if I add 1 hour to 4:03, where do I end up? Make sure you put your tally mark there. You would end up at 5:03. All right. So what time should he be back at his car? He should be back at his car at 5:03. I'm going to use my text feature here, so it's a little bit quicker and neater. All right. Okay, and the last question, these are simple multiplication and division facts. And remember, whether it's multiplication or division, you can use skip counting. So I need to know what times 4 equals 36. If you do not know the fact, you can use skip counting. So I would skip count by 4s till I got to 36. So 4, 8, 12, 16, 20, 24, 28, 32, 36. And I would have 9 fingers. So my answer there would be 9. 9 times 4 is 36. The next one, 3 times what equals 24? 24 is my total. 3 is one of my factors. So I can skip count by 3 until I get to 24. So 3, 6, 9, 12, 15, 18, 21, 24. And that would give me 8 is my missing factor. And the last one is 56 divided by 7. Notice in each one of these, we were looking for an unknown factor. This is division, but we're still looking for an unknown factor. We can skip count by 7s until we get to 56, unless you know that fact. Remember, Mrs. Reed gave you a trick. 7 times 8 equals 56, and then you've got those numbers 5, 6, 7, and 8 all in your number sentence. So I know my answer is 8, but you could also skip count by 7s until you got to 56, and you would still get 8. All right, let's move on to day 4. Day 4 has a 3-digit minus 3-digit equation there. So I'm going to rewrite that with an algorithm, and I'll start with 584. And from that, I will take away 295. And let's see if we have to do any unbundling or regrouping. So again, I line up my digits in the correct places, and then I start with ones. I want to take 5 ones from 4 ones. Well, I can't do that, so I'm going to go over to the tens place. I will unbundle a 10. There's 8 tens there, but if I unbundle one and move it over, I'll be left with 7. But the good news is I'll now have 14 ones. Now I can subtract 14 ones minus 5 ones gives me 9 ones. Now I'll come over and subtract the tens. Well, I can't take 9 tens from 7 tens, and it's really important to think out loud like that. So what can I do? I can come over to the hundreds, and I can unbundle 100. If I have 5 hundreds and I unbundle one, I'll be left with 4 hundreds. But the good news is that gives me 17 tens. 17 tens minus 9 tens will give me 8 tens. And last but not least, I'll subtract my hundreds. 4 minus 2 hundreds gives me 200s, and your answer is 289. Now we have a word problem. It's perfect for this time of year. Haley has 32 marigold seeds. So I'm picturing her having those seeds. Maggie gives her 31 more seeds. So now I know she has more. If Haley wants to divide her seeds evenly into 7 pots, so she's going to put them in pots, if you can picture that, she'll have 7 of them. How many seeds will go in each pot? Well, let's start with what we know. We know she has 32 seeds and somebody gives her more. So she has some and somebody gives her more. What is that, boys and girls? It's part whole. So I want to draw a picture to represent that. So I'm going to draw one part with 32 in it, and that will represent, I'm going to put it an H here for what she already has. And then Maggie gives her 31 more. So I'll put 31 in this part, and I'll put a G under there. That's what she gets. And now what do I want to do with those two? Well, I'm wondering how many seeds she has altogether. So that would be my total here. And 32 plus 31, I can do that mentally. So that's 63. There's no regrouping there. So now I know she has a total of 63 seeds, and she can put divide her seeds evenly into 7 pots. So she's got 7 pots. So how many seeds will she put in each pot? Well, I hear right in the problem, she wants to divide her seeds into 7 pots. So I'm going to take that 63 and I'm going to write a number sentence. I'm going to divide it by 7. And if you know that math fact, you can write it. But if you don't, you can skip count by 7s till you get to 63. So it'd be 7, 14, 21, 28, 35, 42, 49, 56, 63. So the answer would be 9. Probably a good idea, especially if that didn't come easy to you, to draw a picture. So our answer would be 9 seeds. But if you're picturing 7 pots and you're not sure how many seeds are going to go in each pot, well, I'm going to draw a take diagram because that's the easiest thing for me to do with my drawing tool here. Okay, and then I want to divide that into 7 pots because that's one of my knowns. So I'm going to draw 6 lines. 1, 2, 3, 4, 5, 6. If these were fractions, I'd probably split them up again. Okay, so I've got 1, 2, 3, 4, 5, 7. I've got my 7 pots. And now what I would do, boys and girls, is I would start taking those seeds and dividing them fair share into each pot until I got to 63. So that's really what you're doing when you're taking 63 and dividing it by 7. 63 represents the total seeds. 7 represents the number of pots. 9 would be the seeds in each pot or the size of each group. Okay, I'm not going to take time to do that, but you could certainly do that. And remember, it is called, you type it here, fair share, just like you're dealing cards. All right, the next problem, this probably was tricky for you because it's even hard for me to think in terms of metric measurements. It's as a small dog weighs about 15 grams, 50 grams, 5,000 grams, or 15,000 grams. Well, remember, when you think of a gram, your benchmark thing that you're going to visualize is a paper clip. So I'm thinking 15 paper clips. That is not very much. So I don't think a small dog would weigh as little as 15 paper clips. So I'm going to take that and I'm going to cross that off. Okay. Now the next one is 50 grams. So could a small dog weigh the same as 50 paper clips? Maybe, but I'm thinking of a bag about this big with paper clips in it. Still don't think that a small dog could weigh that small of an amount. Now I've got 5,000 grams. So 5,000 grams, remember there's 1,000 grams in 1 kilogram. So in 5,000 grams, there would be 5 kilograms. Remember, a kilogram benchmark is a baseball bat. So do you think a small dog would weigh as much as 5 baseball bats? That seems like a pretty reasonable estimate. If we come down here to D, 15,000 grams would be 15 kilograms. That would be 15 baseball bats, which would probably be too much. So if we want to choose what is probably the best answer, we would say 5,000 grams, which be about the same as 5 baseball bats. All right, and then our last one here is simple multiplication and division equations. 4 times 2 equals, that's right, 8. Remember, you can use skip counting. 6 divided by 3 equals 3, 6, 2. That's your answer there. And 14 divided by 7, can use skip counting. 7, 14, your answer there is 2. All right, boys and girls, I hope I cleared up any misunderstandings you may have on day 3 and day 4 of this week's morning work.